World's biggest abuser of resources is who? So in all the world, humans obviously are the biggest. But what area of humans are the world's biggest abuser of resources? So in the world, what country is the world's biggest abuser of resources? United States of America. Yes. Since we don't even recycle because we send all our recyclable goods to China, who's now not going to take them. So I wonder what we're going to do. If everyone in the world used resources at the same rate that the U.S. consumes, we would need 5 worlds in order to support the 7-point-something billion people on Earth. And we're going to do a resource test. We're going to pick 1 or 2 people in the class. We're going to do a resource test, and we're going to see if this is true. I've had a class where 2 Earths were needed, but normally it's between 4 and 5 Earths based on the activities, the cars you drive, the distance you drive, the food you eat, all those things. Now remember when I showed you the fish presentation? I did, didn't I? Because I keep saying that? Yes. And I talked about fish depletion. Why did fish get depleted? Overfishing, okay. Why did we overfish though?
Food.
We wanted food. Why else?
Selling and trading.
Selling and trading, before even selling and trading, but that's definitely the big issue. Commercial fishing led to serious problems and fish depletion. But why did we fish and fish and fish and fish? Because the ocean was available to everybody. It's what we call a free common resource. So free lands, underline that word, are called commons. And Garrett Harding realized that any part of Earth that is free and accessible to anybody, what do you think is going to happen? We're going to overconsume it or deplete its resources or abuse the land and degrade it. End of story. Give us free land with unlimited resources and we're going to take and take and take. It's programmed in nature. So obviously a perfect example to tragedy of the commons was the oceans. Give me one that you could think of now besides the one I just described. What's another example of tragedy of the commons? Forests, good. Forests were free lands, right? You claim your land, you tore it down, you build your house. Didn't matter what you took in its path, yes? Amazon forest, yes, good. All right, what is biodiversity? Break down the word. Bio means diversity, multiple or variety. So remember I showed you that coral reef that looked empty? Here's what it should look like, right? So it should include a lot of diversity of plants and animals. And when you lose diversity of one species, there's going to be a triple rippling effect, right? Because species depend on each other for survival. If we define pollution, what are we introducing?
Waste.
What's in that waste?
Pollutants.
Which means what? Because we're never going to use that word. What's a pollutant? It can be. Why? Could be.
It's non-degradable.
Maybe. Toxic. So it's going to be something that's introduced to the environment, a chemical, a substance that's going to cause harm to you or the environment or a group of organisms in the environment. You're introducing something at harmful levels, like a chemical. Usually pollution involves some kind of chemical breakdown. And to degrade means to what? We kind of defined this yesterday already. Break down, lower state, right? Take it to another level where it's no longer usable. Climate change or climate patterns have shown an increase in temperature throughout the years, drastic, in the last 20 or 30 or 40 years, a crazy amount of increase. And all you have to know for this unit, because we're going to obviously talk about it, is that it doesn't matter how much you debate global warming or climate change or whatever. If you're a scientist, you believe that this is real. What you question is, what is the contributing factor? Where most people say it's because we burn fossil fuels, which we removed from underground, we burn them and it produces a high level of carbon dioxide into our atmosphere that shouldn't be there, which is a greenhouse gas which causes global warming. So you just want to know for this unit, because we know what fossil fuels are. What are they? Oil, coal. That's a non-renewable good. Petroleum is oil, coal, and what's the other one? Natural gas. Those are fossil fuels. When you burn them, they release carbon dioxide into the atmosphere. Especially, well, not especially, but coal is, we produce for electricity. So that's all I want you to know for that. Waste, by definition. What's waste? Say words that come to your mind when you say the word waste.
Stuff no one needs.
Garbage, good. Stuff what? Stuff you use and discard, yes. Sometimes it's stuff you don't use correctly and then it gets wasted, right? When you use it inefficiently. So anything you use, discard, or carelessly use is considered waste. Someone at the door. All right, so solutions. Obviously, you want to make good choices. This is why this class exists. You want to try to live in a way, and I guess I could lift this up a little so you see it. Live in a way where life can survive and not ruin for future generations. Best solution is obviously prevention. Don't do the problem, okay? Avoid it. We, as in environmental science, we're usually cleaning up the mess. We're not really thinking about how to avoid the mess. In your projects, and I'm saying this in the video, I'm saying it to the whole class and you have it to reference. Don't say don't do it as a solution, because that, of course, is the answer, right? We need realistic solutions because we can't stop. Like, what's the solution to fish degradation or fish depletion? Number one solution. Stop fishing. Can we stop fishing? No. Okay, so I got to think of, somebody said stop commercial fishing earlier. Can we stop commercial fishing? Then, okay, so how many of you fish your own fish? So if we stop commercial fishing, we'll never have fish. Can we live without fish? Sure. But do we want to? Probably not. So what we want to do is figure out how commercial fishing can exist to provide enough fish for the world, evenly distributed, right? So think of those things when you're creating your presentations. Realistic solutions. And obviously, I'm going to end with go green, because if you take this class, the whole purpose is you make one change in your life, and that's already a change for future generations, right? You tell people about your change, you're making even a better change, because very few people know about the topic. Okay, so that's what this class is about, is spreading awareness. Let me see. This is going to be a really choppy video. Am I recording? All right, there'll be no pausing here. Birth of Earth. Anybody know how old Earth is? You saw the 4? It's 4.5 billion years. So we're going to go back 4.5 million years and look at what Earth looked like. Anybody know what Earth looked like 4.5 billion years ago? It was more than a rock, but yes, it was a rock. A rock of what?
Lava.
Yes, but not lava. It was like fire. So Earth, because lava has to flow out of land. So think L for lava, it flowed out. It was just this giant ball of flame of fire, yes? Rolling around, and it was like flowing fire. So kind of you think of lava as flowing, but it's just fire, right? A sea of heat. And then we call that molten rock. Yes? What do you think happened after a while? It cooled. Good. So everything that, by law, heat flows from hot to cold, so that heat just kept spreading out to where it cooled. And what do you think happens when it cools?
Solidifying.
Good job. So it's solidified, forming Earth's crust, or Earth's major first layer, which is called the geosphere, right? Because we got the heat still inside the center of Earth, but we started to form the crust as it cooled. This heat's still there. It's not going to stop, right? It's still inside. Today, that heat is still there, yes? So that heat continued to pour out of the crust, volcanic eruptions. And with those eruptions came what? What do you see?
I would have said islands. Water.
True. Islands are coming. You're right. What do you see in this picture?
Trash being
It's volcanoes. Good. So what's being emitted from the volcano? Gases and lava, yes, which is going to solidify and form more land. These gases formed, well, gases primarily, this you have to know, carbon dioxide for today and water. I promise you there's more gases that come out of a volcanic eruption. Carbon dioxide and water for now because we're talking about Earth's history. So primarily carbon dioxide and water, okay, which created, as you said, our atmosphere. Super thin layer of Earth, right? Now it's primarily, anybody know what it's primarily now? Nitrogen, good. But we don't have to worry about that yet. We'll worry about that in a minute. Then our atmosphere, which from these volcanic eruptions was primarily carbon dioxide and water. What do you think happens next? Nope. We're in our atmosphere and there's carbon dioxide and water, a lot of it. What happens to water in the atmosphere? Well, it's there. It went water. Yes? Then what happens to it? It condenses. Good. Then what happens? After water condenses. That's true. It rained and it rained and it rained until the oceans formed. See how I only have titles, people? This is like a perfect moment to do this. Yeah, I think so. Get ready. And then we had the 3 layers of Earth. Our hydrosphere, our atmosphere, and our geosphere. All in 7 days. Just kidding. So then, Earth is the only planet known to sustain life because of what? There's 3 reasons. Good. Presence of liquid water, because some planets have water, but that we know of, we're the ones with the liquid water. This is what? And yes, you're the 3rd reason. What's this?
light.
Nope. Look at it.
The sun.
Nope.
Atmosphere.
Yes. Our atmosphere, which is that thin layer that surrounds Earth. Well, it's part of Earth, right? And then our distance from the sun. I'm done. For real now.